Resistors are devices that restrict or limit the flow of electricity. They're used wherever a controlled amount of current is needed in a circuit. Everyday carbon film. Resistors like these are used in electronics like appliances and toys, where cost is more important than precision or size. A carbon film resistor is made from a ceramic rod coated with a fine layer of carbon film that conducts electricity with some resistance. A helical groove is cut through the film, leaving a long narrow path of carbon that corkscrews from one end of the rod to the other. Metal caps are crimped onto the two ends, and wire lathes are added. The resistor is then dipped in a protective coating and painted with color-coded stripes to indicate its resistance value. Resistors of this shape are called axial through-hole resistors, meaning they have wire leads intended to go through holes in a circuit board, arranged along the resistor's axis of symmetry.
This high-stability film resistor, about 4 mm in diameter, is made in much the same way as its inexpensive carbon film cousin, but with exacting precision. A ceramic rod is coated with a fine layer of resistive film, thin metal, metal oxide, or carbon, and then a perfectly uniform helical groove is machined into the film. Instead of coating the resistor with an epoxy, it's hermetically sealed in a lustrous little glass envelope. This makes the resistor more robust, ideal for specialized cases such as precision reference instrumentation, where long-term stability of the resistor is critical. The glass envelope provides better isolation against moisture and other environmental changes than standard coatings like epoxy. Wire-wound power resistor. As current flows through a resistor, the resistor converts a certain amount of electrical energy into heat. Most general-purpose resistors have little ability to dissipate heat, as they cannot withstand elevated temperatures. This limits the amount of power they can handle. Power resistors like this one are made without temperature-limiting materials like solder or epoxy, enabling them to handle more power. Some power supplies use them to limit the rush of current that occurs when you plug them in. The active element is a resistive metal wire wrapped around an insulating core. The resistive assembly is placed in a heat-tolerant ceramic shell and filled with cement grout. Thick film resistor array. Many circuits require multiple identical resistors. For example, a digital data bus might need a termination resistor connected in series with each data line, or each I/O pin on a microcontroller might need a pull-down resistor between the pin and ground. A resistor array eliminates the need for multiple discrete resistors. It consists of several resistors fabricated as a single component. Shown here are thick film arrays, named for the fabrication technology, which uses silk-screened conductive and resistive films that are fired like pottery glazes onto a ceramic substrate. After metal terminal pins are fitted and soldered, a laser burns away part of the resistive material to fine-tune each individual resistor to its correct specification. Finally, the array is dipped in an epoxy coating for protection.
Surface mount chip resistor. The most common discrete resistors today are thick film surface mount resistors, also known as chip resistors after their tidy rectangular packages, which lack wire leads. Billions of chip resistors are produced annually and are found in every type of mass-produced consumer electronics. These are surface mount resistors, designed for soldering directly to the surface of a circuit board, as opposed to soldering wire leads that go through holes in the circuit board. They're constructed much like the resistors on thick film arrays, right down to the laser trimming. Subscribe for more videos like this.
Thin film resistors, such as this array, are precision devices manufactured by etching a pattern into an ultra-thin layer of sputtered, vacuum-deposited, metal oxide or cermet, ceramic metal composite. Thin film arrays are used when a circuit requires precisely matched or calibrated resistors, such as for scientific or medical equipment. Each serpentine track of resistive material has several areas that can be laser trimmed to fine-tune the resistance value with increasing exactitude. The solder ball terminals at the end of each resistor allow this array to be soldered directly to a circuit board.